Exponents and order of operations. Exponents are just a way of showing that a number is multiplying by itself a number of times. So if you look here, this is 4 to the third power because it's 4 times 4 times 4. So there's just 3 sets of 4 that are multiplied by each other. This one here, 1c times 1c times 1c times 1c. So this would be c to the fourth power. And it works the same exact way. It's just multiplying this here. And a common misunderstanding is that a lot of times people will just go ahead and go 4 times 3. That is not correct because this, when it's up there, it is not a multiplication problem. It means how many times you multiply 4 by itself. So if it was 4 to the 15th power, it wouldn't be 4 times 15, which is going to be 60. It would be 4 times 4 times 4 times 4 until you get to 15 fours, which is a heck of a lot more than 4 times 15. So obviously that's a significant amount that a significant thing that you need to pay attention to. So when you write something using an exponent, if we have here, if this is a multiplication problem, and this is right here, 12 times 12 times 12, it's all it is counting. It's just 12 is going to be the base, and the exponent is just going to be the amount of 12. So you have 1, 2, 3, 4 that are multiplied by themselves. Now here, this is negative 3 times negative 3 times negative 3 times negative 3. So remember, if there's nothing in between parentheses, that means that it's multiplication, or if there's something on the outside, it would mean multiply the thing in the parentheses. So this is just going to be equal to negative 3 to the fourth power. Now it's very important to keep that negative 3 in the parentheses because it's not 3 to the fourth power, it's negative 3 to the fourth power. For here, this is just going to be, for 8 to the third power, it's just going to be 8 times 8 times 8, which is just, I don't know right offhand, but it's going to be 8 times 8 is 64 times 8, so that's going to be, let's see here, 32. 8 times 48, 512. So that's 512 is what 8 times 3 is, not 24, because it's 8 times 8 times 8. This is going to be 5 times 5 times 5 times 5. And that there, it's going to be 5 times 5, which is 25, times 5 one more time, 125, times 5 one more time. So that's going to be 625. One more time. It is not 5 times 4. It is 5 times 5 times 5 times 5. 4 sets of 5. So you need to write out 4 sets of 5 if there's a 5 and a 4 to the fourth power. Now here, this is just going to be 6 times 6. And that's going to be equal to 36. Now this is an important thing to understand. Again, when you write out 6 to the second power, that just means 6 times 6. You've got to have 2 6s there. You've got to have three 8s here. You've got to have 4 5s here. Just like here, you had to have 4 12s, and you had to have 4 negative 3s here for this problem here. Now these two problems are very different. If you look here, negative 3, the whole thing, squared. It's going to be negative 3 times negative 3. And that's going to be equal to 9. Now this one here, it actually means 3 times 3. And then, remember, you do exponents as quickly as you can. This sort of means that, which simply means, again, 3 times 3, excuse me, get rid of that, 3 times 3, which is going to be 9, and then take the negative of it, because that is what it means. It does not mean that you need to go ahead and do anything with the negative sign there, because the negative is on the outside. If the negative was like this, it would be negative 3 times negative 3. This is 3 squared. Take the negative of it. So 3 times 3, take the negative of it. It's a very important difference that is frequently confusing for a lot of students, so pay attention to that negative sign.